Enterprise digital transformation is hitting a wall. Organizations attempting to process millions of unstructured documents are finding that legacy extraction pipelines cannot scale with the volume or the variety of the data. For decades, the industry standard has relied on a two-stage process: optical character recognition to read the text, followed by supervised machine learning models to extract the meaning. This legacy pipeline is highly brittle. Engineering teams are trapped in endless cycles of retraining their models simply to accommodate minor layout variations from different vendors. We are now seeing a complete architectural replacement. The industry is moving away from probabilistic, context-blind perception pipelines and shifting towards single-pass, multimodal generative extraction. This modern stack relies on three specific components: PyMu-PDF for LLM for ingestion, LangGraph for orchestration, and Gemma 4 for multimodal reasoning. This directly contrasts with and replaces legacy sequence platforms like UiPath Document Understanding. This split-screen blueprint illustrates the difference. On the left is the sequential legacy pipeline. On the right, the unified agentic workflow. Comparing the mechanics of these two approaches shows why the sequential OCR pipeline is being replaced by a more direct, data-faithful architecture. Tracing a digital invoice through the legacy OCR pipeline reveals a destructive first action, flattening the file into a two-dimensional raster grid. Next, binarization classifies every pixel as light background or dark text. Finally, feature extraction decomposes these pixels into geometric shapes to match known characters. This mechanism is entirely context-blind. The algorithm does not know it is reading an invoice. It treats every single character as an isolated visual mark. Because the system is probabilistic, it relies on guessing. A lowercase l and the number 1 share identical geometries. In a dense 10-digit purchase order string, the OCR engine will frequently guess wrong. That single hallucinated pixel is passed down the pipeline. When the automation attempts to match that purchase order against a SQL database, the validation fails. Traditional OCR fails silently. The extracted string looks structurally sound to a human reviewer, but the subtle probabilistic errors permanently compromise enterprise data models. To fix OCR's silent errors, enterprise platforms layer supervised machine learning extractors on top of the text output. These extractors are designed to infer semantic context, like locating the specific text block meant for the total amount field. But these extractors require intensive training. They rely on spatial mapping, learning the exact structural layout of a document so they know where to look. This creates a highly brittle system. If a vendor shifts their invoice table down by an inch or moves the date to a different corner, the spatial automation breaks. To fix those breaks, developers manually draw bounding boxes over the new layout. To mitigate this burden, UiPath uses an active learning loop. Low confidence scores route the document out of the automated flow into a validation station, where a human operator manually corrects the extraction. Active learning does reduce the time required to train the model. However, the core architectural dependency is exactly the same. The system still requires a human to explicitly map the layout.
Applying supervised machine learning over an OCR output does not solve the underlying perception problem. It simply traps organizations in endless loops of training models for structural exceptions. We can bypass this trap entirely by looking at the raw foundation of a digitally native PDF document. PyMu-PDF for LLM is not an OCR engine. It operates as a deterministic bytecode parser. Instead of flattening the document into an image, this parser reads the literal embedded vector text arrays compiled directly inside the file. By extracting the raw digital text directly, this mathematical approach guarantees 100% typo-free extraction. The collision risks of probabilistic OCR are eliminated. It analyzes complex layout structures, identifying headers and mapping multi-column text flows. It then translates those structures directly into clean, token-efficient Markdown, preserving the document's semantic hierarchy. This Markdown conversion reduces the payload weight sent to the large language model by roughly 80%. For edge cases involving scanned documents without embedded text layers, the system utilizes a hybrid OCR strategy. It activates only over unreadable regions, targeting the garbled text while leaving the pristine Markdown layers untouched, cutting processing time in half.
By extracting perfect textual data alongside spatial structure, PyMu-PDF for LLM provides the high-fidelity foundation required for true automated reasoning. Once that high-fidelity markdown is secured, the burden of extraction shifts entirely away from supervised machine learning and moves to large multimodal models like Gemma 4. Because Gemma 4 is trained on trillions of parameters, it possesses zero-shot reasoning. It organically understands the semantic structure of an invoice the exact same way a human does, without any template training. It does not look for predefined bounding boxes, and it requires zero manual intervention when a layout exception occurs. This diagram illustrates the dual-stream multimodal pipeline. Gemma 4 simultaneously ingests the structured markdown generated by the parser alongside the raw 200 dpi visual image of the document. This dual stream allows the model to holistically cross-reference the exact typo-free text with the spatial layout it observes visually. To manage this process, we introduce the LangGraph orchestration layer, which acts as a stateful supervisor for the entire reasoning pipeline. LangGraph enables a tool-first execution. Rather than running a static extraction script, Gemma 4 operates as an agent, dynamically querying the document and executing tools to pull specific line items based on natural language prompts. The combination of deterministic bytecode data and multimodal reasoning creates a self-correcting agentic system. It accurately extracts data from any document layout instantly. Let's return to our split-screen architectural view. We are watching the end of the digitized first, analyze later model. Traditional OCR relies on a sequence of fragmented procedural steps. It requires constant human supervision simply to force probabilistic text into rigid supervised templates. The modern stack collapses that engineering complexity. It executes a single-pass extraction, marrying deterministic bytecode parsing with multimodal reasoning. Enterprise automation is moving toward autonomous agents that recognize a document's meaning and context as a single unified system.